Bharati with Avila Circle, and this time we will move on to the problem number 47. As I told already, the 47 problem says if 34 men completed 2/5 of the work in 8 days, working 9 hours a day, how many more men should be engaged to finish the rest of the work in 6 days, working 9 hours a day. So this is a bit simple, but having a few more information, then it has to be thought in different way. If 34 men completed 2/5 of the work, so that means from there, if I want to calculate the mains efficiency, so that means 2/5 is the target job that they are completing by 34 men working for 8 days and each day by 9. So this is the total time engaged by 34 men to complete this. So this will give you the efficiency. Now if I take it like that, so 34 into 72, so that means 2 can be cancelled, 36. So that is again 36 into 5 is 180. So 180 into 34. So I will not calculate it, rather I will keep it. Maybe possibilities I can cancel it in the other part of the calculation. How many more men should be engaged to finish the rest of the work? The rest of the work means 3/5 of the work has to finish rest of the work in 6 days. So our target for completing this is 6. This is my information, and men to be increased, so I may increase by m. So I am increasing this. This is the information. 6 days working 9, and your time for a day is 6 into 9. So this much the information I have. So I need how many men. So this is the case. So if I calculate with this, the efficiency of the men with this information has to be 3/5 of the work, working with the 34 men, 34 plus m men, increased m quantity, working for 6 into 9 hours. So that will give the efficiency. Now this has to be equal to this. I will put this equal to this. Okay. Now my task will be easier. I will rub it everything up. So only thing 3/5. So this I will reduce. How? Or 3/5 into 6, that is equal to 30. 30 into 9, that is equal to 270 into 34 plus n, there is equal to 1/34 into 180. So I will reduce it. 929333. So now see, the problem is being shortened. Or so there is 34 into 2, 34. So this is equal to 34 plus m is equal to 68. So m is equal to 34. So another 34% to be added to fix the target in the stipulated time. Okay, so this will be your answer. So I'll move on to the problem number 48. Now I sometime may show you some kind of similar problem. Sometime it will be tougher. Next, always if I discuss the tougher problem, there may be not justified for all the students who are seeing. Okay, so that's why I am just mixing the problem where all kind of problem can be seen. Okay, so now problem number 48, it says A can build a wall in 16 days while B can destroy it in 8 days. A worked for 5 days, then B joined with A for next 2 days. Find how many days could A build the remaining work. Okay, so now one is building, one is destroying. That means there may be a possibilities if the wall to be built, A should be faster than B. Otherwise, he will not ever able to complete if both are working for some time. Now to see, either have one chances is that A should be efficient than B. If they are working for same time, then at least he can complete the wall for some time. Or if A is slower, so he has to give a extra time to build, so that when B join, he can lead him by some difference, so that he can complete at least. So this may be the two. So now see, that can be decided once we will come to know the efficiency of those. Now A can build a wall in 16 days, or B can destroy it in 8 days. So that means B is efficient than A. Can see the efficiency of A 1 by 16 and efficiency of B is 1 by 8. That has understood. Now while they are in a mode of opposing to each other, then their efficiency should be deducted from each other, not added up. But because they are not working for the same reason, one is developing, one is destroying. So that means the cumulative efficiency when both are working will be that B minus efficiency A. That would be the equation. So their difference is 1 by 16. Okay, so now this is understood. Now what is the scenario? A worked for 5 days. So within 5 days with the efficiency of A, he has done 5 by 16 part. So the remaining part is 1 minus 5 by 16, that means equal to 11 by 16 part is still remain. Okay, and then B joined for 2 days. So in next 2 days, with their cumulative efficiency, that is this, they can either build or destroy, because B is higher, so this part is the destruction part. B is higher, so that means if I say both are working for 2 days, so they are working as 1 by 8 minus 1 by 16. That I have already calculated, but still I am showing. This could be the difference, because he is destroying, is developing, but as his rate is more, so ultimately this will be a negative impact. So that will be more destroyed. So this is 2 by 16 part. That means 1 by 8 part is destroyed. So whatever he has built in first 5 days, first 5 days, in the next 2 days, if both are doing, so this is the destruction. So ultimate remaining job would be this already built minus 1 by 8 destroyed. Okay, so ultimately this could be to 9 by 16 part is remaining, 9 by 16. Okay, find how many days could A build the remaining one. So as this is remaining, so this, if B left him, A is working together, only working, so A's efficiency is 1 by 16, so my remaining job is 9 by 16. So with this rate, the days needed for A working alone for remaining job 9 by 16 is equal to the fraction of job pending. This is the rate. So fraction of job pending is 9 by 16 and the rate is 1 by 16. So that is equal to 9 more days he need to complete the work. Understood? So we move on to the problem number 49. Now, problem number 49. 49 says the time taken by P alone to finish a work is 50% more than the time taken by P and Q together. Q is thrice as efficient as R. Q is thrice as efficient as R if Q and R together can complete. Q and R together can complete the work in 22.5 days, then how many days will P alone take to complete the work? Fine. So the first one information is the time taken by P alone to finish a work is 50% more than the time taken. So let me assume the time taken by P and Q together be T. So P alone takes 50% more, means 150% of T is the time taken by P, so that is equal to 1.5 of T. Okay, so this is the case. So then efficiency of P alone, if I want to calculate efficiency or rate of work, whatever you say, P alone if I take, so this is the complete work by 1.5 T, whereas rate of work or your this P plus Q efficiency 1 upon T. So this is the difference now. So now if I want to calculate, or let's say if the other information is Q is thrice as efficient than R, so Q is thrice as efficient, so Q is to R is 3:1, that is set. Q is thrice as efficient as R, so this is, and now from here you can say efficiency of P is to efficiency of Q if you want to calculate from this information. So we want to have Q individually, the efficiency of Q is equal to what? That this is cumulative minus P, so that is 1 by T minus 1 by 1.5 T, so that will be 2 by 3 T, so that is equal to 1 by 3 T. Okay, so now this is Q, this is P. So if I further calculate, so remember this, so this will be N, you remember the NP is equal to, so this I will make it in fraction, 2 upon 3T, and this is 1 upon 3T. So if I take the ratio of these two, NP is to NQ is equal to 2 by 3T is to 1 by 3T. Okay, so this will be considered 2:1, and NP, NQ, and NQ this one. So now I have to put it in one frame to get their respective ratio in one shot. So 2:1, this is 3:1, so better I convert it into 6:3. 2:1 is equal to 3:2 because I am to match 3. So now this is 3:1. So all total I can say 6:3:1 is the ratio when they are being compared to each other. Okay, so this is the final form of the ratio of their relation, of the efficiency of their relation between the efficiencies TQR. Now Q and R together can complete the work in 20 to 5 days. So let's say this is any efficiency you can take 6. So part of the efficiency P is 6, 3, 10. This part efficiency of Q is equal to 3 by 10 part. Efficiency of R is 1 upon 10 part. So this can be taken in fraction. Now Q and R together can complete the work in 22 days. So this is the efficiency. Now when Q and R working together, so this is 1 upon their efficiency. This is part of the efficiency. This and this together they can complete in 22.5 days. So in how many days P can complete? So, or rather take it like that, this is in the ratio of P, Q and R, I will take it in PQ and R is equal to 6 is to 3 is to 1. So rather taking in fraction, I take it. It will be easy for me. 6x, Q is equal to 3x and R is equal to x. So in that ratio, when I will add Q and R together, so Q and R is equal to 4x. So 1 upon 4x, that this is the time for both together working is said to be 22 and half. So x is nothing but 1 upon what 4 into 22 and half means 90. So this is 90. Now once x is known, so I will get the exact efficiency. So for by that, what is NP is equal to 6 into 1 by 90. This is the efficiency, and so then the days takes P will take to complete the whole job is given by the exact efficiency 6 by 90. So that is equal to 90 by 6, that is equal to 15 days. So this will be the answer. Okay, so I'll move on to the problem number 50, the last problem for this subject. Then after I'll move on to the other related subjects. As of now, the demanded subject is fluid statistics, but although I will complete the complete fluid mechanics, so that that could be a complete segment of a subject. Fluid mechanics consists of fluid dynamics and statistics both. So in that I could complete the fluid statistics, and I will follow by the some subject question and answer. Okay. So prior to that, let me complete this segment. This is the last problem I will discuss. A tank has an inlet or outlet. Yes. The last problem is a tank has an inlet and outlet pipe the inlet pipe fills the tank completely, in 2 hours when the outlet pipe is plugged. The outlet pipe empties the tank completely in 6 hours when inlet pipe is plugged. If there is a leakage also which is capable of draining, if there is a leakage also which is capable of draining out the tank, out the liquid, draining out the liquid from the tank at half of the rate, from the tank at half of the rate of outlet pipe, then what is the time taken? Then what is the time taken to fill the empty tank when both the pipes are opened. Okay, so now let me read it out again. A tank has an inlet and an outlet. The inlet pipe fills the complete in 2 hours when outlet is closed. Outlet pipe can empty the fluid in 6 hours when inlet is closed. So they are individually working 2 hours and 6 hours. What is the extra one is there is a leakage also which is capable of emptying, which is capable of draining out the liquid from the tank at half of the rate of the outlet pipe. The outlet pipe can empty it in 6 hours, so that leakage has a capability of empty it in 12 hours. So the rate of the inlet pipe is 1/2 and the rate of the outlet pipe is 1/6 and the rate of the leakage is 1/12. So now when both the pipes are open and without saying anything, that leakage will sustain, it will be there. So you no need of saying that it is open. Leakage is a leakage, it will always be there. So what is the cumulative efficiency? Cumulative efficiency is what? Inlet pipe is filling and both outlet pipe and the leakage is draining. So this, with this difference, it will be a position to fill the tank. If this is higher than this, then only tank will cumulatively will fill, and after some time it will completely fill. So if it is the case, let me check. Half minus this will be how much? 12 T by 12, that is half, minus 1/4. So obviously this is more, so I am getting. So the cumulative efficiency when all three are working is half. So that means with this efficiency I have to fill the tank 1/4. So the time taking by to complete filling 1 upon that efficiency, that is equal to 4 hours. So this will be the answer. So this is the end of the time and work session. I think I have sufficiently discussed problem that have a variety of ideas you can get out of it if you can go through all the problem, and I don't think any other problem that will give you any means trouble during solving. If in any case you find any difficulty, I am always there. You can put your questions in the comment box or can directly message me to my number 70329674660. So I will definitely solve it for you, and very promptly I will give you answer. So thank you for now. Hoping I will move on to the next subject. That would be very interesting subject for you. Keep watching my videos. Try to spread it to your groups, your known people, so that more students can get the advantage. Thank you.